So good morning. We got a lot to get to today. So let's get started with a little warm-up action from class on Monday. While you're doing the warm-up problem, I will come around and I will collect the 2 homework problems that are due today. Okay? All right, here we go. So, already set up for substitution, so I'm going to put that in place of y into my equation, which gives me x squared plus y squared minus 25 equals 0, but y now is 2x minus 10. Okay? So then I got to go through and I got to square that term. So that's going to give me x squared plus 4x squared minus 40x plus 100 minus 25 equals 0. That one. Then I can combine terms. That gives me 5x squared minus 40x plus 75 equals 0. Oops. What? Fit in the right spot. Divide everything by 5 gives me x squared minus 8x plus 15 equals 0. That's factorable. 2 numbers that multiply together to be positive 15 and add to be negative 8 are negative 3 and negative 5. So then I set those 2 equal to 0, and I get 3, and I get 5. Now I have to put those back into the equation. So we'll start with x equals 3. If x equals 3, then I've got 9 plus y squared minus 25 equals 0. So that's going to give me y squared minus 16 equals 0. So y squared is 16. So y is plus or minus 4. If I put it into the other one, then I've got y equals 2 times 3 minus 10. 2 times 3 is 6. 6 minus 10 is negative 4. So I can get rid of the plus or minus there, and I can just go with 3, comma, negative 4. For that one. Then I've got to do 5. Plug that in and I get 25 plus y squared minus 25 equals 0. That's y squared equals 0, so y equals 0 there. Plug it into the other one. Y equals 2 times 5 minus 10. 2 times 5 is 10 minus 10 is 0, so my other point then is at 5, comma 0. And both of those check out in that equation. Or in those equations, I should say, in that system. Yes? Okay. All right. So today what I wanted to talk about is I wanted to talk about elimination as a way to solve a system of equations, or a quadratic system of equations. Okay. So the first step in elimination of a quadratic system is we need to line up the equations. Just like it was in a linear system of equations, you want to get the x's lined up, the y's lined up, the number or the equal signs lined up, and the numbers lined up. Okay? Well, here, now what you want to do is you want to line up the x squareds, then the y squareds, then the x terms, then the y terms, then the numbers, and then equals 0. So that one goes to there. Actually, let me make this be the green. We'll make that be the green. And then we'll put the purple. So then you got x squared minus y squared, and then it's minus 16, and then it's equal 0. And then, now you look for, like, elimination. You want to eliminate a squared term. So you might have to multiply one or both equations by a scalar number to set that up. Okay? But you've done that before. In this particular case, I've got plus y squared and I've got minus y squared. So those y squareds get eliminated. When I add the equations, I get 10x squared minus 90x plus 200 equals 0. So step 1, 2, and 3 are all kind of combined. Okay? You gotta line them up, get it so that you eliminate one of the squared terms, and then add the two equations together to eliminate that one squared term. Okay? So we did that. Step number 4 says, now we've got to solve that equation. So I would divide that blue equation, I would divide them all by 10, because we can, to make it easier. So that gives me x squared minus 9x plus 20, and that's going to equal 0. Two numbers that multiply together to be positive 20 and add to be negative 9 are negative 4 and negative 5. So I get x minus 4 and x minus 5 as factors there. So then x minus 4, actually tap the brake, let's stay in color coordination here. X minus 4 equals 0. And x minus 5 equals 0. So x is 4 and x is 5. Now what we have to do is we have to find the points of intersection for these two wonderful conics. My question is, this top conic, what is it? This one right here. We got faith. It's an ellipse. Why is it an ellipse? So two squared terms that are being added together with different coefficients makes an ellipse. Love it. Okay? So it makes an ellipse. Okay? Bottom one. What's this bottom one? What you got, Sam? Why is it hyperbola? Two squared terms we're subtracting it. Is it an up-down parabola or is it a left-right parabola? Or excuse me, not parabola, hyperbola. Up-down hyperbola, left-right hyperbola. Left-right, because x squared comes first. Yep. Okay. So in what ways can a hyperbola and an ellipse intersect? This is key because this is going to tell us how many points that we have to possibly find. What if the ellipse is right there and the hyperbola is right there? How many intersection points do they have? None. So 0 is a possibility. Okay, which means no solution is on the table. What if it's like that? 1. What if it's like that? 3. 4. So I could be looking at upwards of 4 points here, right? Okay. So I got to keep that in mind as I'm going through, because I've got to check to make sure that I've got all the points that I need. Okay. So we've got x equals 4. And we're going to put it into the top equation. 4 squared is 16 times 9 is 144 plus y squared minus 4 times 90. 360 plus 216 equals 0. 144 minus 360 plus 216. 0. So I get y equals 0 on the first one. Yes? Okay. Second one. 4 squared. (16 minus 16). 0. If I add y squared to both sides, then I get 0 equals y squared, and I get 0 equals y. So that gives me the point here of 4, 0. Yes? Okay. Now we got to go to 5. 5 squared. 25 times 9. 225 plus y squared. 5 times 90. 225 minus 450 plus 216 gives me 9. What do you got? Negative 9. So I get y is plus or minus 3 there. Okay. And now we've got to go to that one. 5 squared is 25 plus, oops, nope, tap the brakes, that's minus. Minus y squared minus 16 is 0. So I get 9 minus y squared equals 0. 9 equals y squared. plus minus 3 equals y. So out of that one, I get how many points? Just out of x equals 5. I get how many? 2. What are they? Can an ellipse and a hyperbola intersect at 3 different points? Yep. Okay. Questions on that one? Try that one. Y squared terms cancel each other out. Leaves me with 2x squared minus 16x plus 30 equals 0. All 3 of those can be divided by 2. Squared minus 8x plus 15 is equal to 0. Factors to be x minus 5 and x minus 3. So x is equal to 5 and x is equal to 3. So if x is equal to 5, that's going to be 25 plus y squared minus 80 plus 39 equals 0. 25 minus 80 is negative 55. Plus 39 is negative 16. (25) minus y squared minus 9 equals 0. 16 minus y squared equals 0. So I get both of those. Yep, plus minus 4. So that's going to be 5, comma 4, and 5, comma negative 4. Again, I got a circle this time with an ellipse, right? So basically the same, can be 0, 1, 2, 3, or 4. Okay, so I got 2 so far. Then I've got 3. 3 squared is 9, plus y squared minus 48 plus 39 is 0. That's going to be 0. Yes? Okay. All right. Now, there's one problem. And that problem is what happens if both squared terms get eliminated upon the elimination. Okay? So if I set up these two equations, if I line them up, I get x squared minus y squared minus 12x, leave a space, plus 18 equals 0. And then I line up the other one, I get negative x squared plus y squared minus 4y plus 2 is equal to 0. When I add the equations, my x squareds get canceled out, my y squareds get canceled out, and I'm left over with negative 12x minus 4y plus 20 equals 0. And in that particular case, what I'm going to do, or what I do now, is I pick a variable, solve for it, so I pick a variable and I'm going to solve for it. Easier one, again, work smarter, not harder. Which one's easier to solve for? The y one, yep. Okay. So if I solve this equation for y, I get negative 12x plus 20 equals 4y. Divide everything by 4, I get negative 3x plus 5 equals y. Then what we're going to do is then we are going to use our substitution on that one, and we're going to plug it back into one of the original equations. Now let me see. Oops, nope, I guess I can't. I guess I went too far down. Here I thought I was going to be. Okay, so I'm going to plug in negative 3x plus 5y, or excuse me, negative 3x plus 5 in for y. Which equation, top or bottom, do you want to go into? It doesn't matter. Top one? Okay. All right, so then that's going to be x squared minus y squared minus 12x equals negative 18, but now y is negative 3x plus 5. So I need to multiply that out. That gives me x squared minus, and then this multiplied out is going to be 9x squared minus 30x plus 25. So that's going to be x squared minus 9x squared plus 30x minus 25 minus 12x plus 18 equals 0. I get negative 8x squared plus 18x plus 7. No, minus 7. Equals 0. Not a fan of negatives on my squared term, so I'm going to go one more step here, and I'm going to make this positive 8x squared minus 18x plus 7 equals 0. And it is factorable. I know it's got to be 7, and I know it's got to be 1. And if I go 4x here and 2x there, the middle two give me 14x. The outer two give me 4x. Together that gives me 18x. Gives me negative 18x if I put both negative signs there. So then, x equals 7/4 on that one, and one half on that one. Okay. So, extend El Pacho there. Oh, perfect. Fits right in there. Awesome sauce. So, we've got x equals 7/4. And I've got to plug that in. So 7/4 squared is 49/16 minus y squared. 7 times 12 is 84. Well, actually, 12 divided by 4 is 3. Times 20 or times 7 is 21. So I get 49/16. Well, let's add the 21 first. So I get 49/16 minus y squared equals 3. So I get negative y squared equals negative 1/16. Plus or minus 1/4 there for that one. Okay. Then 1/2. Right? Yep. 1/4 minus y squared minus 6 equals negative 18. Add 6. Subtract off a 1/4. So that's negative y squared equals negative 49/4. Plus or minus 7/2. So my 4 possible points here are 7/4, comma 1/4, 7/4, comma negative 1/4, 1/2, comma 7/2, 1/2, comma negative 7/2. Since we only put them into one equation, you now have the joy of plugging those 4 into that bottom equation. okay, and seeing if all 4 of them work or not. Okay, I'll give you 5 minutes to get that done. All 4 of them work, all 4 of them not work. What do we got? First one, works, doesn't work. What? Doesn't work. So that one gets kicked out. Second one, work, doesn't work. Works or doesn't work? Robbie, what do you think?
Doesn't work.
Give me another chance.
Works.
It works. I take it you didn't try it. Okay, good to know. Third one, works, doesn't work.
Works.
What?
Works.
Works? Yep, third one works. Fourth one, works, doesn't work. We got you in? Nope, doesn't work. Okay, so just 2 of them work. Now, Robin, not bad. Okay, not bad. Okay, but I'm just saying, because so like you did all that work. You know what I mean? Okay, so look at all this work that we did. Ouch! I just got shocked from it. All that work. We did all that work, and then at the very end, all we had to do was put the numbers in. You know what I mean? And see if we're right or not. To me, that's if I don't do that and I get it wrong, then I'm mad because I wasted all that time and I did all that work. Whereas I just had to do one more thing. And it's fairly simple, you know. It's not like these were crazy numbers or anything like that, and then plug it in and we know if we're right or not. Okay? You know what I mean? So don't give up on it right away. We did all that work. Take that one extra step, and now you know for a fact, I'm right. I'm golden. I got this stuff. Okay? 3 homework problems tonight. Due tomorrow. And if you want to if you want to turn in your textbook at any point in time, you can turn that in at any point in time. Okay? So I'll take those anytime.